Hello everyone. Two isolated conducting spheres, each of radius r and carrying charges q and 2q. They are connected by a wire. Find the amount of heat produced during the transfer of charge from one sphere to the other sphere. So look at the first case given there are two isolated conducting spheres, each of radius r. So we can say here there are two conducting spheres, each of radius r. So same radius is given there. So this is a radius r. This is also radius r. Okay. And what is the charge on each one? The q is the charge on the first sphere and 2q is the charge on the second sphere. Now in second case what they given they are connected by a wire. So in the second case same sphere we can draw here. Okay, but what is happening the two spheres are now connected with a wire. When it is connected with a wire, what will happen the charges will be shared. What is the total charge? Q and 2q. When they are shared, what will happen the 3q divided by 2. Okay, this become 3q divided by 2 and this also become 3q divided by 2. Find the amount of heat produced during the transfer of charge from one sphere to other sphere. So what is the energy conversion is taking place? While it is sharing their charges, the energy is now converted into heat energy. So let's use the energy concept here. First of all, calculate the initial energy. So what is the initial energy here? Say it as UI. What is the initial energy? Initial energy is equal to, we already know the formula for energy, U is equal to Q square divided by 2C. That is a formula, right? So we can use here for the first sphere, what is the energy? That is equal to Q square divided by 2C. Plus, what is the energy of the second one? That is equal to 2Q the whole square divided by 2C. So what is the initial energy here? Initial energy is equal to q square divided by 2c plus 4q square divided by 2c, which is equal to, we can write here, ui is equal to 5q square divided by 2c. So this is the first equation. Now when they are sharing their charges, see what is the final energy. We can calculate here what is the final energy. Okay, so we can write it as uf. What is a uf here? So energy on first sphere, what is energy on first sphere? Equal to 3q divided by 2 the whole square divided by 2c plus 3q divided by 2 whole square divided by 2c. So what is answer become? We can write here 9q square divided by 4. So here it become 8c plus same thing 9q square divided by 8c. So what is the final answer? 2 times 9q square divided by 8c, which is equal to 9q square divided by 4c. So this is the final energy. Here you can look at this one. Initial energy is 5q square divided by 2c, but the final energy is now reduced to 9q square divided by 4c. So there is an energy loss is there, and that energy is lost in the form of heat energy. So what is the heat energy produced here? The heat energy is equal to initial energy minus final energy. So you can subtract this one, that is equal to 5q square divided by 2c minus 9q square divided by 4c. Take the common thing outside. So q square divided by 2c can be taken outside into 5 divided by 1 minus what is remaining one is coming the 9 divided by 2. So what is the final answer? Which is equal to q square divided by 2c into, answer is 10 minus 9, that is equal to 1 by 2. So answer is equal to 1 by 2, which is equal to q square divided by 4c. So there is no option given there. In terms of K is written there. So what is the capacitance of the spherical conductor or an isolated conducting sphere? That is C is equal to 4 pi epsilon 0 into R, right? So substitute this value here. So you'll be getting the Q square divided by 4 into 4 pi epsilon 0 into r, that is equal to kq square divided by 4r. So what is the answer here? We are getting final answer kq square divided by 4r. As we already know, 1 by 4 pi epsilon 0 is equal to k. So kq square divided by 4r is the final answer. So option A is the right answer. Hope you understood this one. Thank you.